Today's video is going to be on predicting products of a reaction. So you've been writing equations, balancing them. You can tell types of reactions, I'm sure, but now I'm just going to give you the reactants. You got to figure out what the products are, which you've done a little bit when we've done single replacement labs and double replacement labs. So we've got synthesis, decomposition, combustion, and then there's some single replacement, double replacement ones down there as we go through. So I'm going to do like one from each section, or maybe some of them do a few more, and then you're going to do the rest of them. So first thing, don't forget your diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Hopefully you got those circled on your periodic table. So synthesis, remember, you should have one product over here. So our reaction here, we have sodium plus iodine. So I'm going to write that over here. Sodium plus iodine. Not diatomic. Iodine is diatomic. Okay, sorry about the glare there. It's hard to see that. Let me move that over. So we got sodium plus iodine. So they're going to form a compound of sodium iodide. Whenever two things get together, you got to look up their charges. Sodium is a +1 charge. Iodine is a -1 charge, so just NaI. Now to balance it, numbers out in front of here, we need to put a 2 out in front of that to get 2 iodines, and a 2 out in front of that to get 2 sodiums. Remember, this 2 means there's 2 separate sodium atoms. This 2 with iodine means you have 2 iodine atoms connected. And over here we have 2 separate molecules of sodium iodide. So that's synthesis. I think you can probably do these synthesis ones, just don't forget your diatomics. Decomposition, starting with one thing, breaking apart into multiple. So first one here, nickel 2 oxide. Nickel is a +2 charge, oxygen's a -2, so nickel oxide goes there. It is decomposing into 2 elements, nickel plus oxygen. So decomposition, splitting apart. Nickel is not diatomic, oxygen is. So you need a 2 there with your oxygen. Okay, now we can balance. 2 out in front of that to get 2 oxygens. 2 out in front of that for your 2 nickels. So if it just gives you a compound, you're going to split it apart into the 2 elements it's in. When you do this one, it's telling you have potassium chlorate. So this one, just so you know, will be KClO3 decomposing. It tells you potassium chloride and oxygen gas. Be careful, potassium chloride is a little bit different from there. Combustion ones. Remember, combustion means burning. Combustion means burning, which you're combining with oxygen. So let's slide this up just a little ways. So here's our combustion ones. Again, combustion is burning, which means oxygen's involved on the reactant side. So zinc combust, we're going to say we have zinc plus oxygen. So combustion means you have something plus oxygen, is burning and oxygen. They're just going to form a compound of zinc oxide. So it's also a synthesis reaction. It's a +2 charge and a -2 charge, so those are equal out, so we're good there. 2 oxygens on this side, 1 on that side, so we need to double this compound. 2 zincs and 1 zinc, so we need to double that to balance it out from there. Next one is called hydrocarbon combustion. So if you have a hydrogen-carbon compound that burns, hydrogen-carbon compound, we've done quite a few just balancing. They always make carbon dioxide and water when it's hydrocarbon combustion. Okay, so we have C8H18, which is in gasoline, burns, so plus oxygen, plus O2. That's an O2 there, just so you know it's a little bit of a glare. Forms, so you have to know this. Whenever you burn a hydrocarbon compound, it makes carbon dioxide, it makes water. It makes carbon dioxide plus water. And carbon dioxide, don't look at my charges, you know water. Now we can balance. I'll tell you this, just to kind of speed things up here. If we try and balance this one, I know we need a 2 out in front of this, but let's see here. If we go in 8, this will be wrong to start with. If we go in 8 here to get 8 carbons, or 8 carbons there, 18 hydrogens, that's going to give us a 9 right here. I would tell you over here we have an odd number of oxygens. There's no way to make an odd number here. So when that happens, we're going to double this out front here. So that makes 2 times 8 makes 16 carbons, so we need to put a 16 out in front of this. 18 times 2 is 36 hydrogens. Oops, sorry. 18 times 2 is 36 hydrogens there. Now we got to add up our oxygens on the right side. So right here there are 32 oxygens. Right here there are 18 oxygens. 16 times 2 for 32, 18 times 1 for 18. That's a total of 50 oxygens on this side. So we need a 25 in there for oxygens. Pretty big number. Last two here, I got single replacement and double replacement. Single and double. Okay, single and double. So for your single double, okay. Sorry, this doesn't say single. These are supposed to be single replacements. For single, you got to check your activity series and make sure the reaction happens. So you have this little activity series here. Remember, only, and you've got cationic and anionic ones. Okay. Remember, elements cannot replace anything above them. So for single replacements, we're going to use this sheet a little bit. So I'll do zinc plus sulfuric acid. That's kind of one of the harder ones. So zinc, all right, there, here, zinc plus sulfuric acid is actually H2SO4. This is a cationic single replacement because zinc is a positive thing. So it's going to replace the positive thing here. Positive replace positives. So zinc will replace, trying to replace hydrogen. So first thing, before we write the reaction, make sure it happens. So in order for it to happen, zinc has to be higher on the list than hydrogen. The element by itself, zinc, has to be higher up than hydrogen, and it is. So this reaction will happen. So zinc kicks out hydrogen. So hydrogen got kicked out. Hydrogen is diatomic. So hydrogen kicks out. Plus you have zinc sulfate left over. And zinc's a +2 charge, sulfate's a -2, so we're good to go there. I think we're balanced out. Again, that's cationic single replacement. This one is an anionic single replacement. Okay, so I'll start it off here. We have potassium iodide, which is a +1 -1 charge, plus chlorine. Okay, chlorine is diatomic, so Cl2. So now this is a negative thing, replacing the negative part of this. So chlorine is going to go over here and replace the negative part of that. Okay, so you're not going to make chlorine iodide. You're going to make potassium chloride, and iodine gets kicked out. So the iodine was kicked out. Iodine is diatomic. And potassium and chlorine form a compound. So chlorine came over here and took iodine's spot. This is a +1 charge and a -1, so just KCl right there. To balance this, we need to put a 2 out in front of this to get 2 iodines. And a 2 out in front of that. If we go down to number 12. Number 12 here, we have silver. That's the element by itself. Oh, I never looked up here. We need to make sure chlorine is more reactive than iodine. I just happened to know off the top of my head. Chlorine was more reactive than iodine. It's higher up on the list, so chlorine can replace iodine. Okay. This next one, we're doing silver plus magnesium nitrate. Magnesium's a +2 charge, nitrate's a -1. So we need to go parentheses with a 2, +2 -1 charge. So silver is trying to replace magnesium. Silver is trying to replace magnesium. So we need to make sure silver is more reactive than magnesium. Well, if you look at your list here, silver is way down the bottom, magnesium's way up there. Silver cannot replace magnesium. If you mix those together, silver will not replace magnesium. No reaction. No reaction in that case. I'm going to put the double replacements on another video, so it's not quite so long. Have a good afternoon.